Okay, no, carry on this. For all the documents, this will be our password. No, I think yesterday I put in chat box. Nobody has noticed. Means you are not looking chat box also. For all the documents, we are no space, nothing. Sridhar's notes 108. So this will be your password. Take help of this one. Anything I'll post in your group. This will be the password here afterwards. Okay, read the question. Uh, Take help of the basic maths, what you know. Take help of the basic maths. Definitely the dotted line, this will be the midpoint. It will be from the midpoint O. Let's have a small diagram. There are 4 sources, no? Come for this. Okay, now these are the set of sources are there. Let's get into. So this will be how to analyze two sources. Okay, no, we are able to do 3. Okay, but yes, totally has brought 6. So again, take help of the phasor one, similar to SHM, superposition of more than one SHM. Can you recollect superposition of more than one SHM? The phasor diagram, the same similar method. Yes, for us, he has helped us with an angle. Say this angle is 30 degrees. So these are the S1, S2, S3, S4, S5, S6. So the phasor diagram, no, you look at the S2, S3 and S4. If this makes an angle theta, 30 degrees, the other will be 180 minus theta of the waves arriving here. So the what mathematics you are going to bring into the picture. See it now. So I'll start with. So there's the all almost R is very much greater than A. So definitely what will be the intensity of point P due to all the sources will be same. So therefore I should take the arrows of same length, all of them. Let's indicate. So this angle, this will, the way, like this is theta. I'm not plotting theta. So this particular wave reaches point P. By the time, so it is having 0 phase. So still, if you are unable to understand, so what we are discussing of like this, the wave is here. By the time it arrives here, it will have some phase angle. We don't know how much of that phase angle. So shall we call phi? Same thing for this S3 also, S3 and S4. So therefore, so the S3 and S4 will have the same phase when they arrive here.
They should have different phases. Distance traveled is also different.
Look at R very much greater than A.
Even then, sir, in normal YDSC problems also we take D very much greater than D, but even then we consider the path difference.
Okay, with respect to point, with respect to that line, there is a phase difference between them. I'm showing it, no? You mean to say why these two angles are equal?
Yes, sir.
Okay, no? Huh? So R very much greater than E.
But still there will be path difference, no, sir.
Okay, I will do one thing. I'll solve it. Later you can, at the end you can see that one.
Okay, sir.
Yeah, nothing wrong in thinking. So as R greater than A, no? So therefore I'm assuming that condition. This is A by 2. No. So this will be, again, you look at the point, this will be, so this will be A, this is A, no? So there's a condition. So compared to this particular thing, so how much of additional path the ray 2 will cover? So if this covers, so like so you can altogether we say almost like this will cover some distance A by 2. So when it comes here, so it will cover some additional path, no? So shall we put almost like it's like a 3A by 2 addition it will cover. So for A by 2, if it is having a phase phi, for 3A by 2, additional path should be 3 phi, then this will be 5 pi. The same condition for S2, S1, so this will be S5 and S6. The same angles we can take on this side also. Okay, let's get into the, so I think we can get the resultant phasor, all let have amplitude A. So let A be the amplitude of this one. So the resultant amplitude, and it should be, and it's telling destructive interference. The distance between consecutive sources is A as 0 light intensity. So shall I just add up here, no? So this will be, let amplitude be A. The reason for that, R very much greater than A, let A be the amplitude of the rays at point P. So the 0 is equal to 2A cos phi, 2A cos 3 phi, 2A cos 5. So this everything will become cos phi, cos 3 phi plus cos 5 pi. This should be equal to 0. Any simplification of this? Any value of phase angle? Now, is it justify the phasor diagram? Means like now you can question, sir. Maybe you are drawing as if it is here. If it is as if here, if point P were on the bisector, then this would have been justified, no? The answer. Okay, of course. Here, when it comes here, what will be maxima? See, again, I'm taking you to the YDAC only, no, nothing big. If it were here, it would happen. So by the time it arrives here, due to that path difference, only what the destructive interference will occur, and it will be point P will be 0. So I think what I drew diagram is justified. I'm writing this 0 because due to path difference only, it has become The intensity has been the resultant amplitude as 0 and it has become destructive interference. Anybody value phase angle?
5 equal to pi by 2 and pi by 6.
Only one value, no?
We'll get two values, sir. For any value, it will satisfy.
We should
Uh,
not take pi by 2, sir.
pi by 2 should not be taken, no?
Pi
Should
by
be
6.
less than pi by 2. Okay, pi by 6 I'll take it. Huh? Okay, fine. So there's a phase angle, what we got it. Okay, now after this, what is asking just the value of lambda by A for that to occur. Okay, now the phase angle should be equal to 2 pi by lambda into delta x. What shall I write with delta x? Here I'll come into the picture. So what is the path difference of the rays arriving there? How to bring the delta x, from where to bring delta x? Since r very much greater than a, since r very much greater than a, I will draw the small diagram. What is the angle? This will be theta, this will be theta, this will be theta, this is a by 2, this is a by 2. There's a point P. Now, what to write delta x? That will decide your answer.
Lambda by 6.
No, he's asking, see, we have to find out lambda by a, no? Delta x in terms of a, you have to bring it. So way to indicate delta x is of between what now? So what is
A
this?
cos
This
theta.
a cos theta or a by 2 cos theta?
A by 2 cos theta.
A cos theta, sir.
A cos theta, sir.
No, is it for, what is this phase angle? What we got it? What we should interpret? What is the meaning of this one? No? Until unless we are not clear, we can't go for what is delta x, no?
Phase difference of all the waves reaching point P. Net phase difference.
This will be, so like a, say, here, this will have phase angle when it reaches here. Agree this? This will have the phase angle. What is this phi? Phi is the phase angle of the waves difference. So this will have phi. This when it reaches here, this will have phase angle phi. What about this? This when it reaches here, will have phase angle of 3 phi. This will be 5 pi. So like this. So now shall I say phase angle of the ray 3 when it reaches here? Compared to what? Compared to this one, no? Not compared to this. We are not taking these two as reference. This is a reference. So with respect to this blue color line, so what is the additional path it has covered? So with compared to this, what happened? It has acquired a phase when it arrives here. There is a phase phi. So now compared to this, what will happen? This will move a distance, no? So therefore, I should take equal. Okay, is it agreed? I think Kushal will agree.
Yes, sir.
I should take equal angle only. If I put these two different, it will be then. So we are not comparing between these two. With respect to this line, I'm comparing. So with respect to this line, okay, this is having a phase angle pi by 6. So therefore, the delta x is what? I'll bring it here. Okay, now write it. Cos theta should be equal to delta x by a by 2. So
Sir,
path
phi is
is
pi by 3, sir.
Sir, if we take 2 phi, that time we can take a now, sir. We're considering the phase difference between two sources.
no. I'll just let me wind up. Huh? Then I'll interpret. 2 pi lambda delta x will be a by 2 cos theta. This is okay. Cos theta value. Okay, this will be pi a lambda cos theta cos 30 root 3 by 2. Substituting this, so phase angle is how much? Pi by 6 pi a lambda root 3 by 2 lambda by a 3 root 3. No. So here, see, like we are not comparing between the two rays. That's what here. This phase angle is not. So this phase angle is not between two rays. The phase of a wave 3 when it arrives at point P. Getting this one. So what all this? What is this phase angle? What is this phi? I should say the phase of a wave 3 when it arrives at point P. So I should calculate the path between these two only. So I should go for a by 2, not a. See, only two rays we are comparing. Okay, I'll justify. You just think like YDSC. Here we are having multiple sources. So I'll take the blue color line as reference. With respect to that, I'm defining all other things. More than one sources come, so there are some mathematical difficulty what will get it.
Sir, phi is pi by 3, sir.
This angle, this one,
It's not pi by
Pi
6,
by
sir, pi
3.
by 3.
how much you're getting?
Pi by 3, sir.
Pi by 3. What you, somebody said, I wrote it.
Pi by 6, sir.
5 by 6 only.
Correct only, sir. Pi by 6 only.
5 by 6.
Okay, check mathematics, trigonometry. Okay, let me take here.